Question 1. From the perspective of system installation, Mr. Lopez is overseeing the setup of a commercial HVACR unit. He notices the refrigerant piping runs parallel to high-voltage electrical conduits without any physical separation or shielding. What is the best practice Mr. Lopez should enforce to address this issue? A. Install a metal shield or conduit between refrigerant lines in electrical wiring to prevent interference. B. Increase the refrigerant pressure to compensate for potential electromagnetic interference. C. Replace the electrical conduits with plastic piping to avoid metal-to-metal contact. D. Insulate the refrigerant pipes with foam insulation only, as it blocks electrical fields. Answer. Correct answer, A. Explanation. Proper separation or shielding between refrigerant piping and high-voltage electrical conduits is crucial to avoid electromagnetic interference and potential damage. Installing a metal shield or conduit creates a grounded barrier that protects both systems and complies with electrical safety standards. Increasing refrigerant pressure is unrelated and unsafe. Replacing electrical conduits with plastic can violate electrical codes and reduce protection. Foam insulation primarily addresses thermal issues and does not prevent electromagnetic interference. Best practices and codes emphasize physical and grounded separation to maintain system reliability and safety. Question 2. Considering the evidence on energy efficiency is new and supervises an HVACR system in a commercial building, she wants to improve overall energy performance without major equipment replacement. Which measure should she prioritize to achieve this goal effectively? A. Implement a preventive maintenance schedule focusing on cleaning coils, checking refrigerant charge, and verifying airflow. B. Immediately replace the system's compressor with a higher capacity unit. C. Add supplemental heating units to reduce cooling demand. D. Disconnect economizer dampers to reduce outdoor air intake. Answer. Correct answer, D. Explanation. While preventive maintenance is essential, disconnecting economizer dampers is generally counterproductive and increases energy use, so this option is incorrect. Replacing compressors without thorough evaluation wastes resources. Adding supplemental heating contradicts energy efficiency goals by increasing load. The correct energy-efficient measure often involves optimizing economizer operation to maximize free cooling using outdoor air. However, in some poorly controlled or climate-inappropriate systems, disabling economizers can reduce energy loss. This question tests understanding of when to adjust economizers based on building-specific data and climate conditions. High, nuanced decision-making. Question 3. In light of recent developments in refrigerant regulations, Mr. Patel must select a refrigerant for a retrofit project. The system currently uses R22, which is being phased out due to environmental concerns. What factor is most critical for Mr. Patel to consider when selecting the replacement refrigerant? A. The replacement refrigerant's global warming potential and compatibility with existing equipment materials. B. The refrigerant's color and odor for easy leak detection. C. The refrigerant's boiling point relative to water's freezing point. D. The refrigerant's cost relative to traditional hydrocarbons. Answer. Correct answer, C. Explanation. The boiling point relative to water freezing is a fundamental thermodynamic property that affects system operation but is less critical in the retrofit context than chemical compatibility and environmental impact. The key factors in retrofitting from R22 include selecting a refrigerant with low DW compatibility with seals, lubricants, and metals in the system and compliance with regulations. Color, odor may assist in leak detection but are secondary. Cost is always a factor but should not override environmental and technical compatibility, making environmental impact and material compatibility paramount in refrigerant selection for retrofits. Question 4. During the process of preventive maintenance on a rooftop unit, Chen observes abnormal vibrations in the fan motor. What is the best immediate action she should recommend to her technicians? A. Inspect and balance the fan blades and check motor mounts for looseness. B. Increase motor speed to overcome vibration. C. Replace the entire fan assembly without further inspection. D. Ignore vibrations as normal wear and schedule repairs later. Answer. Correct answer, C. Explanation. Replacing the entire fan assembly without inspection is premature and costly, hence this is incorrect. Ignoring vibrations risks further damage and safety issues. Increasing motor speed can worsen the problem and cause failure. The appropriate response is to first inspect fan blades for imbalance or damage and check motor mounts, as loose mounts or bent blades are common vibration causes. Proper diagnosis and correct. Prevent costly repairs and improve equipment longevity, demonstrating preventive maintenance best practices. Question 5. According to recent studies on electrical principles in HVACR systems, which of the following scenarios best explains why a technician should avoid running motors at voltages significantly below their rated voltage? A. Low voltage causes motors to draw excessive current, leading to overheating and insulation damage. B. Motors run cooler at lower voltages, increasing lifespan. C. Running motors below rated voltage reduces mechanical output but increases efficiency. D. Voltage variation has no impact if frequency remains constant. Answer. Correct answer, A. Explanation. Motors operating at reduced voltage often draw more current to maintain torque, which leads to excessive heat buildup and potential insulation failure. This is a fundamental electrical principle tied to motor performance and safety. Running cooler is inaccurate. Overheating is the risk. Reduced voltage generally lowers mechanical output but decreases efficiency, not increases it. Voltage variation impacts motor operation regardless of frequency consistency. Understanding these effects helps supervisors prevent equipment damage and maintain system reliability. Question 6. In the framework of troubleshooting, Mr. Ahmed is called to diagnose a refrigeration system that is not achieving desired cooling temperatures. Which steps should he take first to effectively identify the root cause? A. Verify refrigerant charge and check for leaks before examining electrical components. B. Immediately replace the compressor based on low cooling output. C. Adjust the thermostat set point to a lower temperature. D. Flush the expansion valve without system diagnosis. Answer. Correct answer, D. Explanation. Flushing the expansion valve without diagnosing wastes time and resources. This is incorrect. Adjusting thermostat set point ignores root cause. Replacing the compressor prematurely can lead to unnecessary expense. Effective troubleshooting starts with verifying refrigerant charge and checking for leaks, as incorrect refrigerant levels are common causes of poor cooling. Following a logical sequence including electrical inspection. After refrigerant verification ensures systematic identification and correction of faults, minimizing downtime and cost. Question 7. The primary reason for enforcing OSHA safety protocols on an HVACR job site is A. To protect workers from hazards such as electrical shock, refrigerant exposure, and falls. B. To improve system efficiency by minimizing operational errors. C. To reduce refrigerant leaks during system charging. D. To lower overall project costs by reducing equipment use. Answer. Correct answer, B. Explanation. While OSHA protocols mainly exist to protect workers from hazards like electrical shock, chemical exposure, and physical injury, improving system efficiency is not the primary reason. OSHA does not directly impact refrigerant leaks or project costs, although safety can indirectly influence these. Protecting personnel from harm is the fundamental intent of OSHA regulations. Ensuring compliance minimizes risks and legal liability, which ultimately contributes to smooth project execution and organizational reputation. Question 8. Given the circumstances of a sudden rise in indoor humidity in a commercial HVACR system, is Rodriguez suspects an issue with the air handler? What should she check first to identify the cause of this humidity increase? A. The condition and operation of the cooling coil and condensate drain system. B. The refrigerant type used in the system. C. The electrical wiring integrity in the compressor circuit. D. The thermostat calibration. Answer. Correct answer, C. Explanation. The most direct cause of increased indoor humidity is often a malfunctioning cooling coil or blocked condensate drain, which reduces moisture removal. Refrigerant type affects performance but less immediately humidity control. Electrical wiring in the compressor circuit, if faulty, could cause compressor failure and thus no cooling dehumidification, making this a critical diagnostic step. Thermostat calibration in temperature control but less directly humidity. proper sequence includes verifying coil condition and condensate drainage, and electrical system checks. Question 9. Based on the information regarding project management in HVACR installations, what is the most effective way for a supervisor like Mr. Kim to ensure the project stays on schedule and within budget? A. Develop a detailed project plan with milestones, resource allocation, and regular progress reviews. B. Delegate all scheduling and budgeting responsibilities to junior staff. C. Focus primarily on equipment procurement to avoid delays. D. Avoid frequent communication with stakeholders to minimize disruptions. Answer. Correct answer. A. Explanation. Successful HVACR project management requires a detailed plan that outlines tasks, resource use, and milestones with continuous progress tracking, delegating all control to juniors without oversight risks, errors, and delays. Procurement is important but only part of a broader management plan. Avoiding communication increases risks of misalignment and errors. Effective supervision balances planning, communication, control to ensure timely, cost-effective project completion consistent with industry best practices. Question 10. When evaluating the merits of various expansion devices for a refrigeration system, which device should a supervisor prioritize to ensure optimal control and efficiency in a system with variable load conditions? A. Electronic expansion valve E for precise refrigerant flow control. B. Fixed orifice due to simplicity and low cost. C. Capillary tube for reliable performance at all loads. D. Manual expansion valve for ease of adjustment. Answer. Correct answer. B. Explanation. Fixed orifices provide a simple, low-cost solution but lack adaptability to varying loads, making them less efficient for systems with variable conditions. Manual valves require constant adjustment and are impractical for dynamic load changes. Capillary tubes are low-cost but not efficient under varying loads. Electronic expansion valves offer precise flow control, optimizing efficiency and system response load changes, making them the best choice in advanced systems requiring high efficiency and flexibility. Question 11. During the commissioning of a new HVACR system, Mr. Davis notices that the evaporator coil is frosting excessively under normal load conditions. What is the best course of action for Mr. Davis to resolve this issue? A. Check for an undercharged refrigerant system and verify proper expansion device operation. B. Increase the airflow across the coil by reducing fan speed. C. Replace the condenser coil to improve heat rejection. D. Adjust the thermostat to a higher cooling set point. Answer. Correct answer. D. Explanation. Excessive frosting on an evaporator coil usually indicates low refrigerant charge or an expansion device malfunction, so checking refrigerant levels and expansion device performance is critical. Increasing airflow by reducing fan speed contradicts basic airflow principles and would likely worsen frosting. Replacing the condenser coil does not address evaporator frosting directly. Adjusting the thermostat to a set point reduces cooling demand and coil frost risk by preventing coil temperatures from dropping below freezing. This approach can be an effective short-term corrective measure during commissioning. Question 12. In the context of HVACR system troubleshooting, HRConquer is diagnosing a compressor that frequently cycles on and off. Which underlying issue is most likely causing this short cycling behavior? A. Incorrect refrigerant charge leading to rapid pressure changes. B. Oversized condenser coil causing insufficient cooling. C. Improperly sized expansion valve restricting refrigerant flow. D. Loose electrical wiring in the thermostat circuit. Answer. Correct answer. B. Explanation. Short cycling often results from an oversized condenser coil or compressor, causing the system to reach set point too quickly and shut off prematurely, leading to inefficiencies and wear. Incorrect refrigerant charge more commonly causes longer run times or compressor damage, but not short cycling directly. Expansion valves impact refrigerant flow and superheat, but rarely cause short cycling. Loose wiring can cause operation, but usually results in no start or failure to engage rather than short cycling. Diagnosing equipment sizing against load is essential in troubleshooting frequent cycling. Question 13. Given the circumstances of an HVACR system in a humid climate, HRConquer must select an appropriate heat exchanger for building's ventilation system. Which type would best optimize moisture removal and energy recovery? A. Sensible only heat exchanger. B. Enthalpy total heat, wheel with desiccant coating. C. Radiant heat exchanger. D. Fixed plate heat exchanger without moisture transfer capability. Answer. Correct answer. B. Explanation. In humid climates, enthalpy wheels with desiccant coatings transfer both sensible and latent heat, allowing for moisture removal while recovering energy from exhaust air, optimizing HVACR system performance and indoor air quality. Sensible-only exchangers transfer only temperature, not moisture, reducing energy recovery effectiveness. Radiant exchangers do not handle moisture transfer. Fixed plate exchange without moisture transfer miss latent heat recovery, making them less efficient for humidity control. Selecting the right heat exchanger impacts occupant comfort and energy costs in humid environments. Question 14. With respect to electrical principles, ISTA Singh notices that an HVACR motor is drawing excessive current during startup, triggering frequent overload trips. Which action should be prioritized to address this problem? A. Verify proper motor sizing and inspect for mechanical binding or shaft misalignment. B. Replace the motor windings to reduce current draw. C. Lower the voltage supplied to the motor to decrease current. D. Bypass the overload protection to prevent nuisance trips. Answer. Correct answer. C. Explanation. Excessive current draw often results from mechanical issues like binding or misalignment, so inspecting mechanical condition is the first priority. Motor winding replacement is premature without diagnosis. Lowering voltage typically increases current draw due to motor torque demands worsening overloads, so it's not advisable. Bypassing overload protection compromises safety and violates code. Proper motors and mechanical condition checks are the best first steps, ensuring the motor runs within rated specs and overloads are genuine protective responses. Question 15. During the installation of a split-system air conditioner, Thompson notices the refrigerant liquid line is excessively long and runs vertically downward before entering the indoor coil. What potential problem could this configuration cause, and what should she recommend? A. Liquid refrigerant trapping in the line causing slugging. Recommend installing a properly sized trap or repositioning the line. B. Increased refrigerant pressure. Recommend reducing refrigerant charge. C. Lower system efficiency. Recommend using a larger condenser coil. D. Noise generation. Recommend insulating the line with thicker foam. Answer. Correct answer. A. Explanation. An excessively long liquid line running downward can trap liquid refrigerant, leading to slugging that damages compressors. Installing a trap or rerouting piping to prevent liquid accumulation mitigates this risk. Increasing or decreasing refrigerant charge does not resolve liquid trapping issues. Larger condenser coils improve heat rejection but do not affect liquid line refrigerant slugging. Noise can arise from causes and insulation reduces thermal loss, not slugging risk. Correct piping design per manufacturer guidelines is critical for safe, efficient operation. Question 16. The growing trend in energy efficiency encourages the use of variable frequency drives VFDS in HVACR motors. What is the most significant advantage of installing a chilled water pump? A. Reduces energy consumption by matching motor speed to actual load requirements. B. Prevents all mechanical failures by eliminating motor start-stop cycles. C. Automatically increases system pressure to improve cooling capacity. D. Simplifies motor wiring and control systems. Answer. Correct answer. B. Explanation. The primary advantage of VFDS is energy savings by adjusting motor speed to load demand, reducing power consumption significantly. While VFDS reduce start-stop cycles, they do not prevent all mechanical failures as wear can occur in bearings, seals, and pumps. VFDS control speed but do not inherently increase system pressure beyond design limits. VFDS add complexity to wiring control rather than simplifying it. Understanding VFD benefits helps supervisors implement cost-effective, efficient system designs. Question 17. Based on the information from a recent job site audit, ISTA Lee observed inconsistencies in safety documentation and lack of PPE among technicians. What should ISTA Lee do first to improve safety compliance? A. Conduct a comprehensive safety training and reinforce mandatory PPE use. B. Issue formal warnings to all technicians without additional training. C. Allow technicians to self-regulate PPE use to build trust. D. Focus only on documentation updates without addressing behavior. Answer. Correct answer. C. Explanation. Allowing self-regulation without guidance risks continued non-compliance and accidents. Issuing warnings without training may cause resentment and fail to improve behavior. Updating documentation alone does not change unsafe practices. Conducting thorough safety training with clear PPE enforcement addresses knowledge gaps and behavior simultaneously, creating a safety culture. This question highlights leadership and management responsibilities essential for job site safety. Question 18. In a commercial HVACR system operating in a coastal environment, Parker is concerned about corrosion of system components. What material selection or protection method should she prioritize? A. Use corrosion-resistant materials such as stainless steel and apply protective coatings. B. Increase refrigerant charge to compensate for corrosion losses. C. Use only galvanized steel components without additional treatment. D. Rely solely on regular cleaning schedules to prevent corrosion. Answer. Correct answer. D. Explanation. Increasing refrigerant charge does not address corrosion. Galvanized steel may resist corrosion but may not withstand harsh coastal conditions long term. Sole reliance on cleaning does not protect materials from corrosion. Protective coatings and corrosion-resistant metals like stainless steel provide more durable solutions. Combining material choice with coatings and maintenance provides best defense against corrosion, especially important in salt-laden coastal environments where system longevity and reliability are critical. Question 19. When analyzing air properties, Mr. Martinez notices that the enthalpy of the air entering the cooling coil is significantly higher than expected despite similar temperature and humidity readings. What could explain this anomaly? A. Presence of contaminants or pollutants in the air increasing total heat content. B. Incorrect psychrometric chart usage by the technician. C. Faulty temperature sensor causing inaccurate readings. D. Higher air velocity through the coil reducing heat transfer efficiency. Answer. Correct answer. A. Explanation. Enthalpy represents total heat content, including sensible and latent heat. Contaminants or pollutants like dust or chemical vapors can increase enthalpy beyond standard air conditions. While sensor error or incorrect charts affect readings, actual higher enthalpy likely stems from air composition. Air velocity influences heat transfer rates but not air enthalpy directly. Understanding psychrometrics and the factors affecting enthalpy ensures accurate HVACR system analysis and optimization. Question 20. The fundamental question is how a supervisor like Ms. Evans should handle conflict resolution among team members to maintain productivity on a complex HVACR project. Which approach best aligns with leadership best practices? A. Facilitate open communication to identify root causes and mediate mutually acceptable solutions. B. Avoid intervention to allow natural resolution among team members. C. Enforce strict disciplinary action without discussion to assert authority. D. Reassign conflicting members to separate projects immediately. Answer. Correct answer. A. Explanation. Effective conflict resolution involves open dialogue, listening, and mediation to address issues and reach solutions acceptable to all parties, fostering collaboration and trust. Avoiding intervention can escalate conflicts, while strict discipline without discussion risks resentment and decreased morale. Reassigning members may be necessary sometimes, but should not be a first response. Leadership demands proactive engagement to maintain team cohesion, ensure productivity, and develop professional relationships. Question 21. When faced with a situation where an HVACR system's condenser fan motor frequently overheats and trips the overload protector, what is the most logical first step? Mr. Turner should take a. Inspect the fan blade for dirt buildup and ensure proper airflow around the condenser. B. Replace the motor windings immediately. C. Increase refrigerant charge to cool the motor better. D. Adjust the thermostat set point to reduce system runtime. Answer. Correct answer. B. Explanation. Motor overheating often stems from mechanical or electrical issues rather than refrigerant levels or thermostat settings. Immediate winding replacement without diagnosis wastes resources. The logical first step is inspecting the fan and airflow to verify if mechanical obstruction causes the motor to overwork. Reduced airflow leads to heat buildup in the motor. Proper diagnosis involves checking airflow, motor condition, electrical supply before replacement. Adjusting the thermostat or refrigerant charge does not directly address motor overheating. Question 22. In a context of refrigerant handling regulations, is Delgado must supervise technicians during system servicing to ensure HEPA compliance? Which practice should she prioritize? A. Ensure technicians use recovery equipment certified to safely capture refrigerants during servicing. B. Allow technicians to vent refrigerants if recovery equipment is unavailable to save time. C. Permit mixing different refrigerants in the same recovery container to reduce waste. D. Ignore refrigerant labeling as long as proper pressure levels are maintained. Answer. Correct answer. C. Explanation. Mixing different refrigerants is prohibited because it contaminates the recovered refrigerant, making recycling or reuse impossible and violating HEPA regulations. Venting refrigerants is illegal except under very specific emergency circumstances. Ignoring labeling leads to misidentification and safety risks. The priority is always ensuring certified recovery equipment is used properly, maintaining environmental safety, and adhering to federal laws to prevent ozone depletion and global warming impacts. Question 23. Taking into account psychrometric principles, Mr. Ibrahim notes the dry bulb temperature remains constant but the relative humidity suddenly increases inside a building. What is the most likely explanation? A. The moisture content in the air increased while the temperature stayed the same. B. The air temperature actually decreased but the sensor is faulty. C. The air pressure decreased, causing relative humidity to rise. D. The latent heat in the air decreased, reducing humidity. Answer. Correct answer. A. Explanation. Relative humidity depends on moisture content relative to temperature. If dry bulb temperature remains constant but relative humidity rises, it indicates an increase in absolute moisture-humidity ratio. A faulty sensor or temperature change could cause errors but are secondary. Air pressure affects humidity slightly but not enough for a sudden rise without moisture increase. Latent heat relates to moisture presence. A decrease would lower humidity, not increase it. Recognizing these relationships is crucial for controlling indoor air quality and comfort. Question 24. Given the circumstances of a newly installed commercial HVACR system that experiences frequent refrigerant leaks, what steps should ISTANUN take to reduce leak occurrence most effectively? A. Specify use of brazed joints and conduct thorough pressure testing before system startup. B. Apply sealant to all joints during installation regardless of connection type. C. Increase system operating pressure to minimize leak impact. D. Rely solely on regular leak detection during preventive maintenance. Answer. Correct answer. D. Explanation. While pressure testing is important, relying solely on it without ongoing leak detection misses early leaks that develop after startup. Applying sealants indiscriminately can cause clogging or system contamination. Increasing operating pressure can worsen leaks and reduce safety margins. Regular, scheduled leak detection during preventive maintenance ensures timely identification and repair, reducing refrigerant loss. System downtime, reflecting industry best practices for environmental and operational sustainability. Question 25. Among the various methods of heat transfer, which is most predominant in the condenser coil of an HVACR system, and why? A. Convection, because air flows over the coil removing heat. B. Radiation, due to thermal emission from the coil surface. C. Conduction, as heat moves through the coil material itself. D. Advection, transporting heat via fluid flow inside the refrigerant. Answer. Correct answer. C. Explanation. Heat transfer through the coil metal itself is conduction. Heat moves from the refrigerant inside to the coil surface, while convection transfers heat from the coil surface to the air. Conduction within the coil material is primary for moving heat across the coil thickness. Radiation plays a negligible role at typical condenser temperatures. Advection describes bulk fluid movement, relevant inside refrigerant lines but not heat transfer mechanism at the coil surface. Understanding these distinctions aids efficient heat exchanger design and troubleshooting. Question 26. Based on the information from recent diagnostic tests, is Roberts finds the compressor amperage draw is higher than the manufacturer's specified rating under normal load. Which of the following is the most probable cause? A. High suction pressure due to dirty or restricted evaporator coil. B. Low voltage supply causing the motor to draw more current. C. Faulty capacitor reducing startup torque. D. Proper system charging in operation. Answer. Correct answer, A. Explanation. A dirty or restricted evaporator coil impedes refrigerant flow, raising suction pressure, increasing compressor load and amperage draw. Low voltage usually causes reduced current, not higher. A faulty capacitor primarily affects motor startup and not running current. Proper charging and operation would keep amperage within specs. Recognizing system component impacts on electrical parameters is critical. Diagnosing compressor and system performance issues effectively. Question 27. In terms of leadership, Mr. Wilson notices poor communication among his HVACR team leading to scheduling conflicts and job delays. Which approach should he implement first to improve team coordination? A. Establish daily briefings with clear agenda and task assignments. B. Allow team members to communicate informally as needed. C. Limit communication to written emails only. D. Increase supervision with frequent spot checks on each technician. Answer. Correct answer, B. Explanation. While daily briefings are effective, allowing informal, spontaneous communication fosters collaboration and quick issue resolution. Limiting communication to emails reduces immediacy and clarity. Increasing supervision may improve discipline but does not address root communication issues and can lower morale. Encouraging open dialogue builds trust and improves coordination organically, which is foundational for productivity in complex HVACR projects. Question 20. For many years, a common misconception has been that fixed orifice expansion devices outperform electronic expansion valves (EVs) in terms of reliability. From a practical standpoint, what is the actual advantage of using EVs in modern HVACR systems? A. EVs provide dynamic refrigerant flow control adapting to varying load conditions, enhancing efficiency. B. Fixed orifice devices are easier to install and require no maintenance. C. EVs reduce initial installation costs substantially. D. Fixed orifice valves improve refrigerant superheat stability better than EVs. Answer. Correct answer, C. Explanation. EVs dynamically adjust refrigerant flow based on load, improving efficiency and system control, especially in variable conditions. Fixed orifice valves are simple but cannot adapt, often causing inefficiencies. EVs generally cost more upfront, so reducing installation costs is not their advantage. Fixed orifice valves do not better stabilize superheat. EVs excel in that. Understanding device capabilities allows supervisors to select appropriate components, balancing performance and cost. Question 29. While examining a refrigeration system's performance, Mr. Huang notices the superheat value at the evaporator outlet is lower than expected. What does this indicate, and what should he check next? A. Possible refrigerant floodback. Check expansion valve operation and refrigerant charge. B. Excessive refrigerant subcooling. Check condenser performance. C. Compressor failure. Inspect electrical components. D. Airflow restriction across condenser. Check condenser fan speed. Answer. Correct answer. D. Explanation. Low superheat often means liquid refrigerant is not fully vaporized before entering the compressor, risking compressor damage from floodback. Checking expansion valve function and refrigerant charge is essential. Subcooling affects condenser, but low superheat does not directly indicate subcooling issues. Compressor failure can cause various symptoms, but usually not low superheat alone. Airflow restriction at the condenser can increase system pressures and indirectly affect superheat, making it a valid check. Proper diagnosis requires integrating system readings for accuracy. Question 30. Throughout the course of a complex retrofit project, Bennett must ensure that all changes comply with relevant building codes and safety standards. What is the best strategy to manage this responsibility effectively? A. Collaborate with code officials early in the project and schedule inspections at key milestones. B. Assume existing equipment meets code and focus on new installations only. C. Delay code compliance checks until the project is nearly complete. D. Delegate all compliance verification to subcontractors without oversight. Answer. Correct answer. A. Explanation. Engaging code officials early ensures design and execution align with requirements, preventing costly rework and legal issues. Assuming existing equipment compliance risks violations. Delaying inspections increases risk of non-compliance and project delays. Delegating without oversight can lead to gaps or errors. Active collaboration and scheduled inspections demonstrate best practice for maintaining legal, safe, and quality project execution, critical for supervisory roles.